Hi, I wanted to put together a video to help you get through Lab Exercise 2. Lab Exercise 2 is about descriptive statistics, which is a foundational element for preparing data for decision makers. Key aspect of our course is being able to take data and put it in a form where we can summarize it so that way decision makers can be able to move forward with some type of ideas and strategic directions in the business. This exercise is to help you understand the basic fundamentals of descriptive statistics. Once you apply the principles shown here, you can then copy this worksheet that you're about ready to create for future tasks. So the first thing we're going to do is we're going to take this data set here, and I'm simply just going to copy it. I'm going to come over here and I am going to paste it, and I'm doing a little trick here. And this is actually going to be day, and this is actually going to be temperature. I don't need this. I'm going to do a quick little sort here. And this is going to get my data set. I know this was just 14 days, so all this other stuff here at the bottom was really garbage. So just to confirm, that's my data set right there. Okay. So I'm going to go ahead and just format this. There's no specific way I care to have it appear in terms of, let's say, font and maybe even, bold size, etc. But what I do care about in this particular case is the way that the information is presented. And we'll talk about that a little bit more. We don't want that there. Okay, I'm just going to go ahead and make that center. So that makes that temperature day go through. Now this is supposedly 2 weeks of early winter days in Boone, North Carolina, and you can see it makes sense. This actually could be a pretty cold winter, couple of days in winter, because we're starting below freezing right away. So what we want to do is be able to include some descriptive statistics here, and the lectures in the class will be able to provide you more detail of each of these. But so what we're going to do is we're going to do mean, median, mode, standard deviation, skewness, minimum, max, range, sum, and then the count. All right. So I'm actually going to right adjust these, and I'm actually going to use this little baby here. Copy that format there, and then put this right there. All right. So this is equal to the mean. Excuse me, I say mean, I apologize. Mean is the same thing as average, right? So I want the average of this data set. I'm going to go ahead and copy that range, and then go ahead. And now I want the median, and I want the mode. Now here I'm going to want to use mode single, because I'm assuming there's one mode in this particular data set. And I want the standard deviation of the sample, because this is a sample of data. Okay, I want the skewness. All right, and I'm going to use the first one, not P, because P would imply population. And that equals the minimum of the same range, equals the max of the same range. And range is nothing more than the max minus the min, right? So now I want the sum, same range, and then the last thing is the count of that same range. All right, so those are actually my descriptive statistics. And I could take a look at these and provide you with some basic understanding of what's going on here. I'm going to make a couple of edits here. Let me make this a little wider, and then that a little wider. Actually, let's make those the same width. I'm going to go ahead and make them 12. All right. And I'm going to go ahead and put that in there. All right. So that is my table of descriptive statistics. So my average temperature equals my mean, so we know this is a normal distribution. The mode is 38, which is really close to the mean and median. So that also gives me an idea of normal distribution. I have a standard deviation of almost 5. I'm actually going to modify that number. I'm going to bring it down to 4.80. And the skewness, you can see it's negative. I'm going to increase the decimal a little bit just to kind of give me some information here. Actually, I want it to show negative, so let me put that in there. So it's very close to 0, so that tells me it's also, again, pretty normal. I have a range of 31 to 47, 31 being the lowest, 47 being the highest, and that's a 16-degree temperature. If I add them all up, it equals 553, and since we're talking about temperature, the temperature is not the kind of data that you would add up. So this number actually doesn't really mean anything for us, but it is a descriptive statistic. So we're going to include this in our analysis. And there's 14 days, so that kind of works out for us. The real value here is starting to create a histogram. And one of the things that we really need to know about when it comes to histograms is how to calculate our bins. Now, the beauty behind Excel is that you can create a histogram without having to calculate your bins. You can go ahead and hit insert. You can come up here and you can do a basic histogram. For this exercise, I do not want you to do this. There are some reasons for doing that. It's because you need to understand how histograms are put together. So one of the things you need to know is the bins and also the width of the bins. Okay. And the bins is nothing more than a number that we want to determine. Now, the smaller the number here, the less I guess, granularity that we're going to see with our histogram. The larger number of bins will give us more granularity. And what I mean by granularity would be kind of like resolution. And the width of the bins is actually the fact that these are continuous numbers here on the right. And a bin is just simply going to be a predetermined range between x1 and x2 where a number might reside. So since the lowest is 31, we might say from 31 to 33 is bin 1. So that would be a width of 2 degrees, and that's what we would go here. But what we want to do is, like, say if we want 5 bins, we want to determine what the width of each of those bins are based on our data. So the width of the bins is nothing more than the range divided by the width. So we have range here, and it's divided by the width, or the number of bins, excuse me, and that happens to be 3.2. Now, for simplicity, I'm leaving this as 3.2, but there are occasions where you might want to make the bin width a little bit wider. So I'm keeping that there, and but just know that over time it may end up becoming something you may want to change. What you want to make sure of, though, is that that bin width is not smaller than this number. So if anything, you want to increase it, but you do not want to decrease it. All right. So next we're going to get into another set of calculations. We want to know the bin number. Where does that bin start? And then we're going to then create a range. And so, for example, bin 1, 2, 3, all the way up to 5. Remember, we wanted 5 bins. And I'm starting with 0 here for a reason, and that'll make sense in a moment. And we're going to put this together here as well and see how this will come out. But for brevity, I'm going to pause here, and I'm going to pick up from this point in the next video.